Welcome to this explainer. I am absolutely thrilled you're here today because we're tackling a topic that sounds, honestly, like pure science fiction, but it's literally reshaping the financial world right under our feet. Today, we're popping the hood on cryptocurrency. Our goal here is to take all those intimidating, highly abstract concepts, blockchains, nodes, cryptography, and break them down into something you can actually wrap your head around. No jargon, no confusion. Just a clear, step-by-step look at how decentralized money actually functions.
But before we get into the nitty-gritty mechanics, I really want you to think about this. How do you trust a financial system that literally has no boss? Think about it. When you put your money in a traditional bank, you're trusting a whole hierarchy of people, right? You've got tellers, branch managers, the CEO, government regulators, the whole shebang. But crypto, it completely eliminates all of those people. There is no central authority calling the shots. So how on earth does a system with zero leadership prevent utter chaos? Well, that is exactly the core problem we're solving today.
Okay, let's dive into this. Here is our roadmap for how we're going to break this down. First, money without a middleman. Second, the 3 core pillars. Third, the anatomy of a transaction. And finally, reaching global agreement. All right, kicking things off with Section 1, money without a middleman.
This right here is the fundamental difference between your standard banking app and a crypto wallet. At its absolute core, cryptocurrency is a decentralized digital currency designed to be used over the internet. But it's that second part, without a central authority like a bank or government, that's the real game changer. Unlike the US dollar or the euro, which are tightly controlled by central banks, crypto completely flips the script. Instead of relying on one single, centralized bank to verify your transactions, cryptocurrencies use a vast, distributed network of computers to manage a public ledger. But, how does that distributed network actually pull this off safely?
Let's look under the hood in Section 2, the 3 core pillars. This bossless engine relies entirely on 3 interconnected concepts to replace the middleman. We're talking about blockchain technology, decentralization, and cryptography. Now, I know you've probably heard these buzzwords thrown around online a million times, but today we're going to examine exactly what each individual component does before we actually see them all spinning together. Let's start with a big one. Pillar number 1 is the blockchain. And the absolute best way to think of a blockchain is just as a digital ledger, basically a giant digital record-keeping book. But here's the catch. Unlike a physical book locked away in a bank vault, this ledger is duplicated and distributed across an entire network of computer systems. Every single time a transaction happens in the crypto world, it gets bundled together with a bunch of other recent transactions into what's called a block. And what happens next is absolutely crucial. Once that block of transactions is full, it's chained directly to the previous block. This continuous chaining process creates a permanent, unchangeable chronological timeline. Because of how tightly they're linked, it's set in stone. You can always look back through the history, but you can never, ever rewrite it. It's a completely permanent record of every exchange that has ever happened on that network. Which brings us to pillar number 2, decentralization. Let's contrast these two for a second. Traditional banks, they keep their records hidden away in a highly private, centralized database. Cryptocurrencies do the exact opposite. Their ledger is totally public, and it's stored on thousands of individual global computers, which we call nodes. And why does this matter? Well, if someone tries to maliciously alter the record on their one single computer, say to give themselves 1 million extra coins, the thousands of other computers will instantly compare that fake ledger to their own copies. They spot the lie immediately and just reject it. It's this massive cross-checking that makes fraud incredibly, almost impossibly difficult.
Now, what's really interesting about this next slide is how we actually interact with that ledger. That's pillar number 3, cryptography. To send and receive crypto, you use a digital wallet that relies on pairs of cryptographic keys. Think of your public key exactly like an email address. Anyone in the world can see it, and anyone can use it to send you money. But your private key? That is like your top secret password. It's what actually proves you own the funds, and it is the absolute only way to authorize outgoing transactions.
But here is the catch, and it's a big one. Because there's no central bank, there is absolutely no forgot my password button. None. In fact, it's estimated that billions of dollars worth of Bitcoin are just lost forever, simply because people misplace their private keys. If you lose that key, you lose access to your money permanently. There's no customer service hotline to call if you mess up. The stakes of managing your own key are incredibly high. It's total financial freedom, but it comes with total personal responsibility. Let's move to Section 3 and see how this all builds together in the anatomy of a transaction. So we've seen the parts,
the blockchain, the nodes, the keys. Now let's actually watch the machine operate. When a transaction happens, it doesn't just magically teleport. It goes through a very strict, automated 5-step sequence. We've got initiating the transfer, broadcasting to the network, validation and mining, adding to the ledger, and finally, completion. Let's walk through this with a quick example. All right, step 1. Let's say Alice decides she wants to send 0.5 Bitcoin to Bob. To kick off this transfer, Alice opens her digital crypto wallet. She types in Bob's public address, which remember is just like his email address. Then, to make the transaction legitimate, she authorizes the whole thing using her secret, private key. Moving to step 2. The second Alice hits send, those transaction details are broadcast out to that vast network of global nodes we talked about earlier. But hold on, it's not done yet. Right now, Alice's transfer is basically thrown into a massive waiting pool. It's sitting there as an unconfirmed transaction. It's essentially just waiting in line to get checked. Steps 3 and 4 are where the real heavy lifting happens. Network participants, who are usually called miners or validators, grab Alice's transaction from that pool and bundle it up with others into a brand new block. Now, they have to verify that Alice actually owns that 0.5 Bitcoin and, crucially, that she hasn't already spent it somewhere else. Depending on the network, these folks either use massive computing power to solve complex math puzzles, or they lock up their own crypto as collateral. The moment the puzzle is solved and the network confirms everything is perfectly legit, boom, that new block is permanently added to the existing blockchain. Which brings us to step 5, completion. The exact second that block is added, the ledger updates across the entire global network simultaneously. Bob checks his wallet, and there it is. The 0.5 Bitcoin has arrived. The transaction is final, and it is entirely irreversible. The money is successfully moved from Alice to Bob, all without a single bank ever being involved. Pretty amazing, right? But wait, if thousands of independent computers are all updating at the exact same time, how do they actually agree on who solved the puzzle or which block is the right one? That takes us to section 4, reaching global agreement. Because there isn't some CEO or bank manager sitting there banging a gavel saying, yes, this transaction is valid, the network relies on something called a consensus mechanism. Think of this as an automated mathematical referee. It's a built-in process that a completely bossless network uses to agree on the absolute truth and keep everything secure. And this brilliantly illustrates the 2 main ways they do it. First up, proof of work, which is what Bitcoin uses. Here, computers literally race to solve those complex riddles for the right to update the ledger. The winner gets rewarded with newly minted coins. But this race requires massive amounts of electrical power, sometimes more than entire countries use in a year. On the flip side, we have proof of stake, used by networks like Ethereum. Instead of an energy-hungry race, participants basically stake or lock up their own crypto as collateral for a chance to validate. Validate correctly, you get a reward. Try to cheat the system, you lose your collateral. It makes proof of stake incredibly energy efficient compared to proof of work. But at the end of the day, both systems are solving the exact same crazy problem, getting thousands of total strangers to agree on a single financial reality completely without a middleman. Which leaves us with this final thought. We've seen how the blockchain creates a permanent timeline. We've seen how decentralization kills fraud, and how cryptography locks down your identity. It really is a masterpiece of modern engineering. But ultimately, it all boils down to trust. So I'll leave you with this. Would you trust a vast, bossless network of computers with your life savings? It's a question that is literally defining the future of finance, and I hope this explainer has given you the knowledge to figure out your own answer. Thanks so much for joining me to break this all down and keep exploring.